Guys, Arlene's gonna explain to us what she did here. Okay, so please go ahead.
Okay, so I copied down the problem, and then I found v of t, and I did that by finding the derivative. So the derivative of t is 1, and the derivative of 9 over t plus 1 is all of that. So then I didn't really show my work, but it's like right here for the to find the t for the zeros for v of t.
Oh, to find the zeros.
Of t is like right here.
Oh, here.
Yeah. And then. So,
What are the zeros?
2.
Just 2?
It was 2 and -4, but time can't be negative.
Okay.
So,
Did you guys hear that? Time can't be negative. Okay.
so I just got 2, and then I found a of t, which was the derivative of v of t. So like after all the work, I got that. And then I did these thingies, the line graphs. And then for v of t, I put 0 on the left and 2 in the middle. And when you plug in a number from 0 to 2 into v of t, you get a negative. And if you add, and if you plug in a number greater than 2, you get positive. So then I did the same thing for acceleration, but I plugged it into this one. So you just get positive all the way across. And then when velocity is negative and acceleration is positive, you slow down. So on that side, you're slowing down. And on this side, because they're both positive, like they're both the same force, you speed up. And then for position, I plugged in the times into the normal one.
But wouldn't that be 10?
What?
Putting 0?
For the normal one?
Yeah.
You get 11.
You get 0.
0 plus 1 is 9 plus 1.
0 plus where is it?
And the thing's a 10.
What? It should be 10.
I don't know. You plug in 0. Oh yeah, you would get 10.
Because it would be 9 over 1.
Point is you're here, and then you go back, and then you go forward.
What questions do you guys have for Arlene? Wait, leave it there. Thank you.
Oh, okay.
Thank you, Arlene. Yes.
I understood the question. I just have an overall question about
Okay.
this. So when we're graphing it, where do we mark our position? When we find t for velocity, or when we plug in t for position?
Okay. Say that one more time.
When we where do we mark our position?
Where do you mark? You mean where do you make the ticks?
Yeah, like there's at one point. I mean.
Okay, so I think what you're asking is how do you know that the tick should be at t equals 2?
Yeah, I mean, 'cause that's our time. Right?
Uh-huh.
Time.
Okay, yes. Okay, so that's a great question. So first you find, and it's in the steps that was listed in the notes. First you find velocity, and then you find out when velocity equals 0. Meaning you find the zeros of velocity. So you find when does v of t equal 0, right? And she didn't show her work, or she did it really lightly, but she let this whole thing equal 0, and she solved. And she found out that when t equals 2, that's weird. Oh yeah, when t equals 2, the velocity is 0, right?
I'm just confused about like the position and time. So is time our
Time is your x-axis. And position is your first function. It's f. And then velocity is f prime. And acceleration is f double prime. So once we found when velocity equals 0 at t equals 2, and that's going to be here. So I guess you're asking this. This is the x. T is here in this row, and then the velocity here is here in this row. It's kind of like when you're doing an XY chart, right? You know how back in the days we used to make XY charts? It's kind of like that on a number line form, except the x is t and the y is f prime, which is v. So we only really use, in this problem, we don't really use position except to figure out this part at the end. Okay? Are there other questions related to Arlene's problem? No? Other general questions? Yeah.
Alright, you know how we plugged in for position? We plugged in t equals 0, t equals 1, t equals 2.
Uh-huh.
How do we know how many times we have to plug in?
Why did you find t equals 1?
Why?
I didn't?
Why did you? Why did you plug in 1?
I don't know. I wasn't here for the lesson, so I just.
Oh, okay. So you didn't have to. You only really, because look, what did she actually find in the end? Okay, in the end, she found that t started at position at 11, and then it.
Yeah, it's 10.
Oh, 10. Sorry, this should be 10.
Yeah.
It started at 10, and then it went went backwards to 6.5, and then it went to does this be 2?
No, because when t equals 3, it's 2.
When t equals. What?
Wait, what did you say?
No.
When t equals 2, it's 6.
It was like 11:30.
Yeah, when t equals 2, it's 6.
Oh, where's 6? Is this 6.5 or 6? Okay, let's do this again.
Yeah, we can erase the whole thing.
Okay, so okay. Okay, so we start at 10. Okay, so we start at 10, right?
Right.
And then
1 second.
after 1 second, it moved to 6.5. But we don't actually care about that, okay?
Go from 0 to 10.
Because, well, what do we really care about when we talk about a particle's motion? We care about where you start. What else do we care about?
Critical point.
Critical points. That's why they're critical.
Oh,
Where
so
you
it's
stopped, right?
2.
Or where you turn around. So we care about where you start and where you turn around. And then that's pretty much it, because this thing just turned around and then it kept going in the opposite direction. So we don't really need this. I appreciate that you found extra data, but you don't need it. So we do want to know, first of all, t does not equal 2 does not equal 6.
It doesn't?
That's a false. 2 does not equal 6.
Oh, S of
Okay? When t equals 2, s of 2 equals 6. Okay?
Oh.
That's okay. 0 does not equal 3. Or 0 does not equal 10, right? So s of 0 equals 10. Okay? So be very clear on that. We don't need that. Okay, so at 2 seconds, okay, so basically we know that v of t equals 0 when t equals 0 or t equals 2. And that's why we plug in these two. We want to find the position at those 2 points. At the beginning, it's at 10, and then it turns at 6, right? So it goes to here by 2 seconds. Okay? And then what happened after that? It turns around. So then it just goes that way, right? I guess you can say. Okay? So first it went that way, and then it went that way. Okay? Okay, let's look at, does anybody have another question from the homework? No?
What do you mean by motion? Oh.
Motion is it speeding up or speeding down? Let me borrow this for a second.
Okay.
Yeah. So let's look at number 3. Did you guys notice that the velocity, the critical points are when the velocity equals 0, and it equals 0 at 2 and 4. But acceleration changed because it went from positive to negative at 3. So to know where to put the tick on this line, on the A line, you have to let A equal 0. And acceleration equals 0 at 3, right? And so then you put that there, and then you test. Okay, over here is positive, over here is negative. And then you line it up. Every tick you see, you put a tick for 2, and for 3, and for 4, so that you could do negative times positive is negative, positive times positive is positive, positive times negative is negative, negative times negative is positive. So you're kind of combining these 2 lines, sandwiching these 2 lines together in this line and then that gives you the information. So these two lines give me a lot of information. This tells me like where the position where it starts, stops, and stuff, and this tells me if it's slowing up or down. And if you put these two together, can you make like a little animation or something to show me what it does? Yeah, right? Okay? Alright. Well, I said I was going to give you guys a quiz on this, and I will.
Bring it on.
But let's do the word problems first, okay? So we'll leave the quiz for tomorrow. Okay? And I won't be here tomorrow, so that works out.
So the word, there's gonna be word problems on the quiz tomorrow?
Yes, yes. So it'll be a quiz on section 3.4a. So let's talk about this. And don't try to be absent tomorrow, please. Only I get to do that. Celebrate Halloween by yourself at home. You're like trick-or-treating by yourself. Okay, so you think we can move on, right? We don't necessarily need to do this example, yeah? Because it's the same. Whoa, that is close.
Is this on notes now?
Yeah, this is notes. How do I live without you? How do I ever survive? How come this is not working? Yes? Yes. Sorry, give me a second. I'm trying to figure out. Control panel, presentation mode. Somehow my function F8 is broken. Oh, connect to projector. Did you forget to go to football?
No.
How could you forget to go to?
Football's a habit now.
Yeah.
Oh, and doing calculus is not a habit.
I played football for 4 years. I've done calculus for like 8 weeks.
But don't you do homework in math? Didn't you do math homework every year?
Ugly truth.
No. TBH.
You gotta break the
I think about doing it every year.
every year. You said every year.
Once a year. That every blue moon, I think about it. And I think about the consequences.
And then it passes. 'Cause
And then it passes.
You see the full moon in your life. Life's great.
All right. Okay. Here we go. All right. I'm sure that my friend Stu had a reason to do example 4, so let's take a look at what example 4 actually showed.
Hold off the line. Hold forward.
So your friends,
Doing analysis is part of the direction
What was that?
your friends also like teach.
I do have friends that teach calculus. Yes.
Comes from Bible study?
No. He's an artist.
Is this the type of word problem you're gonna put on?
No. Okay, so let's look. Okay. Okay, proxima. Okay, when an object, you with us, Rob? When an object is subjected to gravity, the position function is given by s of t equals negative 6t squared plus v naught t plus s naught. You guys know this, right? Do you guys remember this from physics?
We're in physics.
Oh, did you guys?
Yeah, the initial velocity.
Yes. Woo! Robert came alive. Okay, so this is the position of an object on Earth. Okay, this only works for Earth. Don't try this away from Earth. Okay. When we're on a different planet, we'll have a different body. We'll have a different gravitational pull. But on Earth, this is what gravity does. It takes an object, and when an object is free falling, that means the only thing that's affecting it is gravity, then the position is going to be negative 16 times how long it's been falling squared, plus its initial velocity that it started falling at times how long it's been falling, plus its initial position. Okay? This is an upside down or a right side up parabola?
Upside down.
Upside down parabola. So that shows that your s, your position is actually going to decrease, right?
Yeah.
And of course, the other half of the parabola, okay, the other half of the parabola, by the way, that's going to be where s of naught, right? S, the initial, doesn't count because that's when time is negative, right? So if we're just looking at this part, because time can only be positive, so basically if my position is going to be, I'm going to fall, and notice how the position, it's kind of exponential. The position drops faster later on. That means when you actually drop something on Earth, it's like falls, and it falls faster and faster.
9.8.
Huh?
9.8 meters per second.
Okay, that's for meters. And for feet, it's negative 16. Okay?
So you fought negative 16 feet per second?
Yeah, exactly. Okay, very good. I love the connection with physics. You guys are learning physics with Mr. Bertuccio? Okay. Oh, you're learning. Oh, this is your second year learning physics?
She's an 8.
Nice. Okay. Okay, so it's measured in feet. Velocity is initial velocity. That means the velocity when time was 0. Okay, when would the initial velocity not be 0? What does it mean, initial velocity, when something's falling?
When it starts.
Okay, but don't you start at 0?
Yeah. Unless you're thrown.
Unless you're thrown. If you thrust an object down, then it has an initial velocity. If you just like release it, then it has an initial velocity of 0. Okay?
Unless you detrude an object. You know what detrude means? To thrust down.
To what?
To thrust down.
What is the word?
Detrude.
Detrude. I did not know that. Thank you. That's a new word. Detrude an object. Okay, S naught is the initial position. That's where it initially started. How high did you start at? The formula is given by this if we're measured in meters. Oh, so it's not negative 9.8. Where would the negative 9.8 come from?
It's 9.8. Gravity is 9.8 meters per second.
Well, the negative is because we're talking about position. Okay, never mind. We'll get to it. Okay, I think I'm always like preempting this guy in. Okay, from our original equation, we can calculate the velocity function. What is velocity?
Negative 32 square. T.
Negative 32t plus v naught. Okay. And the acceleration function is? Negative 32. This is the acceleration due to gravity on Earth. Okay? Do you guys kind of see what this means? The velocity with respect to time. Because the velocity changes, right? As time changes, the speed changes. The velocity changes. Initially, when time is 0, the velocity is just going to be v naught. Right? But as time passes, that initial velocity decreases. With every second, it decreases by 32. So let's say I throw something down with an initial velocity of negative 100 feet per second. So it starts at a negative 100. But after a second, it's going to be going faster. It's going to be going negative 132 feet per second. And after that, it's going to be going 164 feet per second. Yeah, and so that just shows you that as you throw some, as time passes, the velocity gets bigger, or no, it decreases, okay, but the absolute value of that, the speed, is actually increasing, so it's falling down faster. All right, now, yes,
The acceleration due to gravity is negative 32 feet
per second squared.
This is when it's going down.
Mm-hmm.
It's negative.
So it's constant. So if I'm talking from gravity's point of view, it's just 32. But since it's going, you're not necessarily going down, but since the wind is pushing down, gravity's pushing down, it's negative. I mean, if you're just thinking how far away am I getting away from my initial, like if you're, it's your perspective, right? Now hold on. Why is acceleration constant?
Because gravity is constant.
The force of gravity is constant. Do you agree? Does gravity change?
Nope.
Does the wind
Sometimes.
that gravity exerts
What if?
change?
What if?
But on Earth, this whole time we're assuming we're on Earth, right?
Oh, so we only use that formula.
Yeah, when we go to Mars, you guys, on our field trip, then I'll give you the new formula, which we will cover in the next unit or next section. But for now, let's stay on Earth.
Why do you sound so serious?
Okay? It's true. Okay, and then Brightstar has a big budget for, LELs. Okay, that's where all the money's going. AP Calculus field trip. Okay, so what if we're talking about meters? Okay, can you guys tell me the velocity for meters?
For meters?
Uh-huh.
Negative point four point.
Oh, it's going to be negative 9.8.
No, negative 9.8.
That's what
Oh, is that where that's coming from?
And the acceleration?
Negative 9.8.
Plus V.
Okay,
Well, why is it negative then?
because the wind is going down. Gravity is pushing you down.
So gravity is 9.8, and then acceleration is negative 1.
Negative 9.8. No, acceleration is negative 9.8.
So the velocity is not negative 9.8 plus v naught.
Yeah.
But I thought
Acceleration
it was
is
only
just
negative.
negative
You were going up, and then you go down, and it becomes positive.
No.
Yeah, 'cause
The
it's like-
motion is speeding up. That positive means that it's getting faster. The speed, the absolute value.
And we'll go to
It's
Bertuzzi.
going down faster.
That's why it's 9.8.
Mm-hmm. But the negative part means that which direction is the force? The force is towards the ground. Let's do some concrete examples. Maybe it'll help. Okay. When an object is thrown upward, it is subject to gravity. We are usually interested in how high the particle reaches, right? Those are the things that are of interest to us. How high the particle reaches and how fast it is going when it impacts the ground.
Or water.
Or water. Let us analyze what
So
these
the
mean.
maximum potential energy when it impacts
You
it?
just said that yesterday. How do you remember?
Because I do. Whenever he hit the floor, it was the maximum potential energy.
Okay. Let's make some more connections here. When an object reaches its maximum height, what is the velocity?
0.
Right?
You want to teach us that?
Okay. So, to find the maximum height of an object, set v equal to 0. Solve for t and find s of t.
Position.
You get it?
Wait, so you solve for...
Because when I throw something up,
Whoa.
the highest point, at that highest point, the velocity was 0, right? And so if I want to find the velocity position, let it equal 0, however long it took that time that made the velocity equal 0 is the time where it turned. Plug that time into the position, and that tells you how far it went up.
Can you do it again so we can see the
Okay.
I want to see it stop.
So,
I don't see it.
when does the object reach its maximum height?
Wait, so like, you know how
The object reached its maximum height when v equals 0. But this is a graph of s, okay?
V of t?
Yeah, when v of t equals 0, right? Because what's the velocity at the highest point? 0. So if you do that, you can find out solve for t, right?
S is distance, right?
Yeah, the position, not distance, position.
Is that the same thing as displacement?
No, because displacement is an final position minus initial position, which is distance. Well, no. Distance is different from displacement.
Yeah. And then what's the difference with
Position is just a point where I am right now. So if my position is 15, and then later my position is 10, my displacement is -5. But my position right now is 10. Okay? Okay, so this is a graph of position, okay? But I know that I don't know where this position is. I'm trying to figure out what that highest position is. But I know that that highest position happens when the velocity equals 0. So if I let v equal 0 and then solve for t, that tells me how long it took me to get to the highest position. Once I find out what that t is, I could plug that t into my s, and that tells me how high I went. Okay? Now we're all talking abstract. We'll do it in a minute and it'll make more sense. Okay? Okay, well when an object, the other question we care about is when an object hits the ground. What is its final position? I mean, the other question is when an object hits the ground, what is its impact? Okay? Alright, well, when an object hits the ground, what is its final position?
0. Negative
0, right? Is
Oh,
it?
I said bounce it.
Okay, well when it hits the ground, the position is 0.
How come it bounced on the table but doesn't bounce on the table?
Okay? That's a good question.
Well, because the paper absorbs the impact more.
I think it has to do, I don't know what that word, there's a word for the hardness.
Is that
The
what
density?
That's related.
Is that the thing where about the books on the bill?
Yeah, it absorbs the impact. The paper absorbs.
So the more hair you have, the better.
Well, the paper.
Okay. All right. So we're getting a little lost here. So to find the velocity of an object when it hits the ground, let s equal 0. Because when s equals 0, that means it's either when you start or when you end. And when you let s equals 0, solve for t, and then plug that into v, and that tells you at that last second, because it tells you when the last second is, what's the time that it reached the ground. At that time, what's the velocity? It tells you the impact.
So you're trying to find for final velocity?
Final velocity.
And can you use like the kinematics equations?
Say that again.
Can you use kinematics?
What is that? Teach me.
Like the
Teacher of physics, Catherine.
like their physics equation.
Okay, I want you to think about how the physics equation fits in with the calculus, okay?
Physics is calculus.
Just a different name.
Okay, well, let's see. Okay? Because you probably did these same problems then in using physics equations, but now we're going to do it using calculus. Okay, a projectile is launched vertically upward from the ground level with an initial velocity of 112 feet per second. So now we're getting into word problems. Have we done word problems yet in this class?
Not
Oh, it's finally hit the real world?
Not never.
Okay, so this is V naught, okay?
We know.
So basically something is happening, it's got tossed up and it goes back down, right? So find the initial velocity and speed at t equals 3 and t equals 5. Oh, sorry, not the initial. Find the velocity and speed. So velocity at 3 and the speed, okay.
Velocity at time
3
equals
and
3. What?
Yeah, so after 3 seconds, what is the velocity?
Yeah. And then
Well, plug it in.
To where?
to what equation?
To what equation?
They didn't give us an equation. Oh, now we gotta do something.
Okay. What is our equation?
It seems to
Our position is negative 16 t squared plus the initial velocity plus we don't, okay, it's tossed up from the ground.
So how do you know which one to use?
It depends. It doesn't really matter. They didn't specify, but let's use feet, okay?
Plus 0?
Oh, because the initial velocity is speed.
Yeah. You're right, it does specify. That was a nice learning moment. Do you guys see where that equation came from?
Yeah.
They told me the initial velocity, they told me the initial starting point, so I could plug him in.
But you did it. Oh, then I'm gonna do that. Oh, never mind. That's a T.
Okay, so this one applies to any time you're throwing something on Earth, anytime something's subject to gravity. Gravity.
Oh, John Myers?
Mayor. I love it.
Mr. Computer.
Okay.
That's my book.
All right, so
You can't see anything.
no, Dan Myers, guys. You guys don't know Dan Myers. He's a famous math celebrity that I met this weekend and last year.
How are you a celebrity from math?
One day I'll be a famous math celebrity and you'll say, oh, she was my teacher.
Won the Nobel
Okay,
Prize.
alright. So negative 16, 3 squared plus 112 times 3.
You don't have to find the derivative.
What?
Oh, I'm so sorry, Miss Han.
Oh my goodness. Yeah, here we go. Math celebrities, here we go. Start here.
Okay, alright, let me focus. Alright. Okay, let me get into my thinking cat mode. Okay, so S prime of t, okay? I'm confused because there's like a lag. Do you guys see the lag? Oh, okay. S prime of t is going to be velocity, and so I'm going to differentiate, so it's going to be negative 32t plus 112.
What?
Right?
Negative. Okay, yeah.
So v of, please notice my notation. I don't just say equals all over the place in an untrue way. That was v of t. Now this is a different page. This is v of 3, whereby I'm going to plug in 3, which is negative 96 plus positive 112, which is
That's going to be, 6.
16. Okay, so what does that
Whoa,
mean?
why 16?
Isn't it? Okay.
Yeah.
So, isn't it? Okay, so this is feet per second. So, my velocity was 16 feet per second. So, what is my speed?
Your speed.
And then how do you find
Your speed?
How do you find the speed?
Is the absolute value of 16,
Oh, 16.
which is 16 feet per second.
It's always in the absolute value.
Yep.
Do we have to write speed here? Can we just
Somehow say speed at t equals 3 or something, because we're going to differentiate between that and at 5 seconds. Because at 5 seconds, we're going to do negative 32 times 5 plus 112.
This
that's
is
gonna
going
be,
up. How many down?
It was launched vertically upward, yes.
Negative 160. Negative 160.
So negative, what is it? Negative 160 plus 112.
That's going to be 48. No. Wait.
Yeah, negative 48, right? Feet per second.
The value of 17 is absolute value.
So the speed at t equals 5 is absolute value of negative 48, which is positive 48 feet per second.
Not going down.
Okay? So was the object moving faster at 3 seconds or faster at 5 seconds?
5.
5.
At 5 seconds it was moving faster. But at 3 seconds, was it moving up or down?
Up.
At 5 seconds, was it moving up or down?
Down.
You guys see that? Girls, are you guys doing okay? I have my back to you. You're good?
So then so it was moving, the velocity was negative, but the speed was positive.
Always positive. Speed is always positive,
Can be negative.
because speed is the absolute value. Yeah?
Yeah.
Okay? So that tells us something. Up until 3 seconds, it was still going up, but at some point, it must have turned around, because by the time we get to 5 seconds, it's going down. So I don't know if do you think it'd be right in the middle at t equals
No.
4 is when it turned? Probably not, because the speed, look, is like
Yeah,
different,
yeah.
right? It's not a symmetrical situation here. How high will the projectile rise? What does that mean?
What will it be when
What's
v equals
what's
0?
the distance? Yeah. How high is it going to be when the velocity is 0?
Okay, so what is
So you're going to make v
position
at v of t equals 0?
when
T equals 0. No, that's t is time.
But v of t equals 0.
It's asking the distance,
That's why.
right?
so what should we do?
So you do v of t equals 0?
Find out when v of t equals 0. It's this scenario, right? Find out when the velocity equals 0, because that's when it turned around, and then plug that t into the position, and that's how high it went. Right? Okay, so let's do that. I could do that. I could do that.
So we just copy V of t.
So v of t, so let, that's a good word to know for math. Let v of t, which equals negative 32t plus, no, I was trying to underline it. Let v of t equal 0. Okay? That means negative 32t equals negative 112. So t equals negative 112 over negative 32.
Wait, why are they both negative?
6. It should be.
Is it 6? 6? No.
I got 7 halves. You got 6?
How do you get 6?
I don't know how to do
Can't be
math.
6.
Who knows how to do math?
Can't be 6.
No, that would get 102.
6, yeah, 6 times 2. You get 180.
It's 6?
No,
Since
It's not-
between 6 and 7, because it's not 7. Because for 7 you would get
Okay, wait.
22.
I divided it by 4. Oh, so this should have been 8. Sorry.
What?
7 fourths. No? I'm totally off. I just
Calculator.
get out the calculator. I can't do simple division.
Why can't you?
That's the most. 4?
3.5.
We don't like-
Wait.
3.5.
What's 7 divided by? Oh, 3.5? Isn't that what I said originally?
No.
Yeah, 7 over 2 is
yeah.
3.5. That was right.
Wait, but if you divide by 4.
I know, but I said 2, but I don't know. I flipped out and I.
Oh, because then that can reduce to 2.
Okay, so the thing is, you guys.
If you divide, no. If you divide that by 2, you get 4. No. Wait, I'm lost. Stop it.
Okay, I divided this by 4, I got 28, and then I divided that by 4, and I got 8. So it's 28 divided by 8, and divided that by half is 14 over 4. 14 over 4, that's right. Okay,
7 over 2.
so 7 over 2. But really is, okay, in this case, I guess this is the one time when you're doing real life problems that decimals are better, right? Because 7 over 2, what does that mean? But if I have to do more algebra with it, like square it, would I rather square 7 over 2, or would I rather square 3.5? Yeah, so you see how like algebraically fractions are better, but in real life it's more makes more sense to say 3.5
So then
seconds.
we plug in 3.5
Okay?
then.
So that's when the velocity reached 0, so that's when the thing must have stopped and turned around. So at that time, I'm going to go ahead and plug in what's the position at that time.
Equals negative 16, 3.5.
Negative 16 times, now I'm going to go back to 7 half
Yeah,
square, but you could use your calculator.
No,
Yeah, go ahead, Mario.
So
Just
what's-
tell
so
us,
what's-
tell us.
So what's S naught?
S naught?
Because don't you plug it back into the S of T? Oh, wait. How do you know S naught?
Because it started at the ground level. Okay, what is it, Mario?
336.
But you're gonna get 49
Are you
over
sure?
4. You're gonna get 49 over 4.
I got 196 last year.
Wait, you remember?
No?
I know, right?
I was like, what the? Wait, cause if you wait 49 over
You
4?
did? Your laptop?
Find it.
Well, 3 squared is like, it's like a 10, with a negative 160, and then, yeah, somebody get out their calculator.
Alright, I got
please.
the shoot. Wait, does Ronica got it?
All of you should do it. You should all practice. Get out your calculators, everybody.
What did you get?
196?
Oh, let's hope it's not bad.
Negative 16 times 3.5 times 196?
Oh, it is alive. Alright, so
Can everybody successfully get that on their calculator, please, so I
negative 16
am assured that you know how to use your calculator?
times 49
Would you get negative 196?
Positive.
plus 112 times 7 divided by 2.
Oh, yeah?
I got 196.
You got that one?
Yeah.
Oh, and he just lost his.
I know.
Interesting.
No.
Why'd you
Why'd you get that one?
Why?
Uh-huh.
My uncle ordered it for me.
Oh, okay. I mean, that's cool. It's just hard to understand unless you're
Yeah.
like a genius. But they have stuff online.
I got 196.
That's what I said.
I got
He got me
196.
the book for dummies to learn how to use it.
Oh, good, good, good. What a cool uncle.
I got
Okay, alright, lastly, 196. So that's how high it went up. Find the speed of the projectile when it hits the ground. What does that mean? The projectile when it hits the ground. So what do I do?
The position.
So we're not done?
That means find
Final velocity.
the final velocity, right? When s of t equals 0, right?
You.
Wait, how many times do you think, if you throw something up from the ground, how many times does position equal 0? Twice. When?
Oh,
you
at the
start
start
At the
of it?
beginning and at the end. So hopefully we'll get 2 answers, okay?
Unless
So,
you start it up.
true, true.
Elevated.
But it says it starts at ground level.
Alright, well then in that situation.
Right, that's why.
Specific situation.
So S of t is negative 16 t.
Should be 7/4 this time. You know?
And negative 16 t squared.
Am I doing something wrong?
12
No.
equals 0. So you
Right? Yeah. Right? Because last time we divided by 32 and this time we're dividing by 16.
Okay, and then you got to square root that?
Isn't it 112?
Oh, so it should be,
Isn't it 112 t?
or it should be 7/8. I'm confused.
Yeah, wait. Yeah, it should be
Can you
112.
go through your math again? 112 divided by 16.
Yeah.
Why is it only 112?
112 t, miss.
Is it? Yeah, it's 112 t.
Because s.
Because it's v
S
not
of t
t.
equals.
Thank you.
And then the t.
Wake up, Miss Han.
Wake it up now.
Because that way we have to get, okay. So 112. Oh, there it is. There she goes. Okay, so then, yeah, you gotta factor.
Use your eraser.
Okay, so you factor out a t, so you're gonna get negative 16t plus 112 equals 0, right? So that means t equals 0, or negative 16t equals negative 112, which means t equals 112 divided by 16,
Or
which means last time I divided by 32. So yeah, it should be 7/4. No? No, Miss Han, Miss Han, Miss Han.
wait, why would t equal 0?
Because you have
What's
t
on the
times
outside?
negative 116.
Negative 160.
It should be 7 then.
Yeah, that's what marked. So
Okay.
t equals 0, t equals 7.
Yeah.
But you're not done, right?
No. So that means it started at t equals 0 and it ended at t equals 7. Okay, so what is it asking? Find the speed when it hits the ground.
So at t equals 7.
Yep.
So you plug it into the velocity. And velocity is negative 32.
Should my answer be should the velocity be positive or negative? No, velocity. Negative because it hit the ground going down, right?
Yeah.
Who's got a calculator?
Oh, miss, I got you. That's gonna be 21. That's gonna be 224.
Yeah?
Negative 224.
Right here, dude. Yeah, no, but
I got negative 112.
Yeah, the brain right here. Okay. Wait, 32 times 7? 224.
It's negative 112.
224 minus
That's
112.
112 equals 0.
Negative.
Is that my final answer? Should I bubble in negative 112?
No, Miss Han, because, wait, what's 32 times 7?
You have to find the speed, which is the absolute value of that.
Oh, you see. And then you find the speed. And 112 equals 7.
Positive.
No, that's
Jesus. Right.
Okay?
Have you seen that?
Alright, you guys, any questions on this? Okay. Do your brains feel sufficiently stretched? No?
Was that the
Yes.
warm-up?
Yes.
Yeah, that was the warm up. Now for the real lesson.
Oh.
Example. No, just kidding. That was the lesson. But example 5. Example 5 tells you the equations of free fall on Mars, Earth, and Jupiter. Okay? Free fall. That means the initial velocity is 0.
Yes, if these are real
Okay.
life problems,
Yeah.
why would we have to find the velocity for Jupiter and Mars?
That happens in real life. Do you think it was in a storybook that this exists? Mars is real.
Okay, but we've never
We
gone to
live on
Jupiter.
Earth,
Like, where are we gonna go?
You've never gotten married, but don't you need to know about that? Like,
but we're surrounded by marriage.
are you thinking that none of you here should ever even dare dream about going to Mars? Or
about
create a
Jupiter?
rocket that goes to Mars?
No, never going to Mars.
Back to the matter.
Actually, Josue wants to be an engineer. Maybe he wants to work at
You said
NASA.
mechanical
So I
engineer, like,
believe
you wanna
only
work
the
with
people who want to be
cars.
an engineer should
Yeah,
be
build
out
a
to
rocket
Mars and Jupiter.
If you're never going to be a politician, should you not study U.S. history? If you're never going to be an English teacher, should you not know how to speak English?
What if you live in Mexico?
But if you're learning English and you're in the United States, it's kind of.
That's what I'm saying. Well, we got to elevate the general knowledge of our populace. Everybody should know about Mars, Earth, and Jupiter. Okay? Okay, so how long will it take a rock? Okay, blah, blah, blah. That's just good for you to know. I want you guys to do example 6 right now. Okay, example 6. Your turn.
I just thought about it because you say Mexico.
Quiz tomorrow.
What?
On this too?
Yeah, so finish the homework and there will be a
Wait,
quiz
the
tomorrow.
whole homework?
Yeah.
Oh.
Okay, so you want to just do a practice home problem? Why don't you start the homework, yeah? Start the homework, which is the rest of the problem.
But the homeworks are harder than the actual stuff.
That's true. Should we start with this one then?
No.
Okay.
Wait, so we do the example 5?
What?
No, why don't you just go ahead and do example problem 1? Start with your homework. The rest of yesterday's.
So number
Like, you know how I,
Oh, You're right.